Okay, good evening, class. This is Professor Rourke. I wanted to make a couple of short videos going over some questions that were challenging on the skills assessment. So the skills assessment is tricky because it covers all kinds of topics and they are all over the place, okay? And the ideal is that if we can feel confident about all of these random algebra and pre-calculus topics, then we will be confident when we need to all of a sudden use them because they do come up randomly throughout this class and also into Calc 2 where it's just like, oh, okay, I haven't seen that in a while. Okay, yeah, I remember that. Or, oh, I need a little refresher. So hopefully this is a good refresher so that there's a lot of skills in here that you might need for either Calc 1 or Calc 2. Okay, so or Calc 3 in theory, if you have to take Calc 3. Okay, so first things first, it says find the domain of the function. This is number 5, and it says enter your answer using interval notation. And it's like, okay, I remember that. I remember interval notation. I know that parentheses is what we would use if it doesn't actually include the value. So things like infinity have parentheses and also numbers with like an open circle versus closed circles or brackets. Okay, great. However, the problem is they have two radicals here. Okay, they have the square root of 7 minus x. Your number could have been a little bit different. Mine, whenever it's a red number on mine, it means that's the number that could possibly change. So it could be 5 minus x, 6 minus x. It could be anything. Okay, any number minus x. So that's one radical, and then we also have another radical, x squared minus 1. So the tricky part is we need to make sure that whatever our domain is, these are all the possible x values that would work for either one, okay? Because if there's a number that maybe works for one of these radicals, but then makes the other radical imaginary, that still doesn't count, okay? So we need these whatever numbers are okay for both radicals, okay? So a little reminder, for 7 minus x on the first radical, we want to say it's greater than or equal to 0, okay? Because we can take the square root of 0 and we can take the square root of positive numbers. We cannot take the square root of negative numbers, right? So that's we say 7 minus x greater than or equal to 0. Hopefully that feels okay. And then the other portion is that x squared minus 1 is greater than or equal to 0. And it's always for radicals. It's always set whatever is inside the radical, you set it greater than or equal to 0. Okay, and then we have to try to solve these, okay? And again, we're looking for the numbers that would work for both of these. If there's any numbers that don't work for either one, then they're out of the whole domain. Okay, so for instance, 7 minus x is greater than or equal to 0. If we solve for x, we can do this a couple different ways. I'll just keep it sort of maybe, I don't know, I'll just solve for x by itself. So we'll say negative x is greater than or equal to -7. And then if I divide by -1, we'll say x is less than or equal to 7. Okay, so that kind of ties into when we divide or multiply by a negative number, we have to flip the inequality. Okay, all good? We also could have just added 7, and then we would have said 7 is greater than or equal to x, which is the same thing as x is less than or equal to 7. Okay, so this means that for my domain, I for sure cannot go past 7. Okay, because anything past 7 would make this lovely radical negative. And the numbers of the radical as being negative means I'm talking about imaginary things, and I don't want imaginary numbers in my domain. That wouldn't make any sense. Okay. Domain are just talking about what's real on the graph that we can actually see. All right, next up, I have to try to solve x squared minus 1 is greater than or equal to 0, which is deceivingly hard, okay? Because people often forget what's even going on here. This is a polynomial inequality, okay? So if you need a little refresher on this, if this seems completely new, the reason is because it's a polynomial inequality and it's surprisingly tricky. Okay, it's not as straightforward as linear inequalities like we just solved. There is a bit more involved. So there's a few ways you can approach these. One way is to solve for what we call the boundary points. Okay, so that would just be like pretending, like just pretend that this is not an inequality. Okay, just pretend it's an equal sign to get out the quote boundary points. So if we do that, we can do that. We would say that we could add 1 to both sides and then take the square root and we would get positive and -1, right? We do need to make sure don't forget that if we introduce a square root, we have to put that's positive and negative, okay? Because -1 squared is 1 and 1 squared is 1, okay? So those are my boundary points. Then from here is where things can get a little different. So one option is if you remember, you would go, this is always a little long. I'm not going to recommend quite doing this because I think it's excessive. You have to draw another number line, not to be confused with my number line, like my overall number line that I'm using to keep track of the different domains of my radicals. Just a no number line to focus on solving x squared minus 1 is greater than or equal to 0. Okay, and then you could pick test points in between each interval, plug them into the original inequality and see if they're true or not. If they're true, we would like include that interval. If they're false, we wouldn't. That's a bit long. It's a bit heavy. Okay, it's a bit much. There's a lot like between picking numbers and then plugging them in. It's just like ugh, a lot. So what I actually recommend is sometimes in this class there's just a lot of things thrown at us in a quick amount of time. It's often best to figure out what we can do as quick and as efficient as possible. And often I think what is the most efficient is to think about what the graph is going to look like. Okay, you can even put x squared minus 1 into your graphing calculator if you want, if you don't feel comfortable. But hopefully you understand that x squared is a U-shaped, minus 1 means it's shifted down 1. Okay, so my graph is going to be a real basic quadratic. It's going to intersect my graph at -1 and 1. It was shifted down here to the y value of -1, like a y-intercept of -1. And then we can use this graph, just this knowledge of this graph, or again, my graphing calculator, if you so desire, to figure out where this x squared minus 1 is greater than or equal to 0. Okay, so when it's greater than or equal to 0, hopefully we understand that that means that it's like above the y-axis, right? If it was reversed, if it was less than or equal to 0, it'd be below the y-axis. So hopefully it makes sense. Just for x squared minus 1 is greater than or equal to 0. We're talking about like all the x values. I'll write it in inequality ways and then I'll follow it up with the interval that x is less than or equal to -1. So everything to the left of -1 is above the y-axis, and then x is greater than or equal to 1 is everything above the y-axis as well. Okay, in interval form, we would say -infinity to -1 with a closed bracket. And then we would say 1 to infinity on the right, with the 1 being a bracket and then infinity being in parentheses. Okay, so what do we do with this? We have to tie it back into our original when we talked about that x has to be less than or equal to 7. Okay, so no matter what, remember, we have to make sure it works for both of these. So no matter what, we're not allowed to go past 7. Okay, because if we go past 7, we're messing up our first radical. Can't be doing that. Okay, we can't be having an imaginary number and part of the radical. It makes the whole thing imaginary. We need to make sure it's real everywhere. Okay, so we have -infinity to -1. I'm going to go ahead and try to add on -1. Where do I want to put -1? I don't know. I'll just go ahead and put -1 somewhere over here. And again, we're trying to say that we want it to be less than or equal to. So we're talking about, I'll make it like a double. Okay, so including -1 all the way to the left. And that works for my less than 7, right? That's fine. If I plugged in -2, it would work for both of them. If I plugged in -3, it would work for both of them. It wouldn't make it an imaginary number. I could plug in -1000 and it would work. Okay, I would still have a real number. It could be ugly, but it's real. So that's good. And then I have to add in my second piece here, which is that from 1 to infinity. Okay, so what essentially is saying is that we cannot have anything between -1 and 1. Anything between -1 and 1 makes my radical the x squared minus 1 negative. Okay, like 0, for instance, is no good because 0 minus 1 is -1. And that's square root of -1 is imaginary. So we don't want that either. So what does that leave us with? Well, that just leaves us with then everything from 1 to 7. Okay, those are the only, and then we have to stop at 7 again because we can't go past 7 because anything past 7 makes the radical on the left imaginary. So we don't want that. Okay, so what does that mean? We're going to try to put it all together. We're going to go from negative infinity. If I can spell infinity correct. Yes. Okay. So if you type the word infinity, also sometimes it's helpful. It's up to you. Without having to click the calc pad, you can get infinity over there, but it's up to you. Okay, and I'm going to put -1, and I'm going to put a bracket for the -1 because it includes it. And then I'll go ahead and show you on the sets. You can pick the U side for union. That's what we typically want to say. It's technically saying -infinity to -1, or you also could pick numbers between 1 and 7. And both of those are brackets because it includes both of them. Okay, so I hope that makes sense. That was number 5 again from the skills assessment. Hoping to not talk too long about each of these, but I know there's a few that we want to cover, and I don't want any of them to be particularly long. So I hope that was helpful. Keep me posted, please. I will talk to you soon.